Let's find the area between y equals 2x squared and y equals x to the fourth minus 2x squared. Plotted on Wolfram Alpha, here is the graph in blue of 2x squared, and here's the graph in purple of y equals x to the fourth minus 2x squared. We should always first graph these two functions to figure out what the orientation is. Is one bigger than the other? Does it stay higher throughout the entire thing? And in fact, it looks like 2x squared is above x to the fourth minus 2x squared all the way from where they intersect at this point all the way up until where they intersect at this point right here. So our first order of business is to figure out where these two functions intersect, because this gives me my a, my lower limit of integration, and this gives me my b, my upper limit of integration. So in order to figure out where these two graphs intersect, we can set them equal to each other. So here we have 2x squared is equal to x to the fourth minus 2x squared. We can get 0 on our left-hand side, so we have 0 equals x to the fourth. And we're subtracting, so minus 4x squared. So we have 0 is equal to, we can factor out an x squared, and we're left with x squared minus 4. Of course, x squared minus 4 can also be factored. So we have x squared times x minus 2 times x plus 2. So it looks like they intersect here at x equals 0 from this factor. They intersect at x equals 2 and at x equals negative 2. So we're going from x equals negative 2 up to x equals 2. Now the fact that they intersect at x equals 0 doesn't influence our formula. We're still going to take the integral of our upper function minus the lower function. It's just that at x equals 0, the distance between them is going to be 0. So we'll factor that in. Alright, now that we have our limits of integration, we can set up our formula. So here we have the integral from negative 2 to positive 2 of our upper function, which is the one in blue, which is 2x squared, minus our lower function, which is x to the fourth minus 2x squared. And this is all times dx. Now we're subtracting by the entire function, which means that we have to distribute this negative to both the x to the fourth as well as the negative 2x squared. This is a major issue that many students have. So here we go. We have the integral from negative 2 to 2 of negative x to the fourth plus 4x squared dx. Well, the antiderivative of negative x to the fourth is negative 1/5 x to the fifth. The antiderivative of 4x squared is 4/3 x cubed, and this is from negative 2 up to positive 2. We can now plug in our b, which is 2, and so we have 2 to the fifth is 32 times negative 1 over 5 is negative 32 over 5, plus we have 2 cubed is 8 times 4 is 32 over 3, minus, when we plug in a, we get negative 2 to the fifth is negative 32 times negative 1/5 is positive 32 over 5. And we have negative 2 cubed is negative 8 times 4 is negative 32 over 3. Alright, so we have negative 32 over 5 minus 32 over 5 is negative 64 over 5. And 32 over 3 minus negative 32 over 3 is positive 64 over 3. And this is equal to 8.533. And this is the area between the curves of 2x squared and x to the fourth minus 2x squared. 8.533.